Okay, hello everybody. Welcome to my presentation here about software engineering. So, I originally gave this talk several minutes ago for a high school in Brookfield, Wisconsin, and I'm going back through it because I didn't reach all the slides and I'm just feeling excited. I want other people to be able to watch this because I think it's valuable. Because I'm going to tell you things that I wish I knew having gone into software engineering. I very much picked my major like out of the hat. We'll get into it, but now I know what I'm talking about. So today we're going to talk about software engineering. And ultimately the question that I want to answer for you is, should I being you, pursue a career in software engineering? I've obviously already answered this question for myself, and I have chosen to. So I'm going to help you answer this question by addressing a few smaller ones. One being, who am I? Why should you care? The next being, what is software engineering? It's kind of this big buzzy word that feels like it has more impact than it really is. We'll get into it, as well as how you get into it. How do you pursue a career in software engineering? What does that look like? And then ultimately answering, how do you know if this is right for you? And I want to clarify that a very reasonable outcome of this presentation is like, I don't want to do this. This is not for me. Maybe that's you. It wasn't me. I almost thought it was. I'm not trying to spoil too much, jeepers. But these are going to be the questions that we address today. So, first, me. Since I'll move my little face. So I've included some pictures of me so that you know like where I'm coming from, who I am. So you can see here, this is one of my IDs from a former job. So I am in fact credible. Somebody paid me to be in tech engineering, whatever that means. I also play the drums. Sometimes I cosplay as Ruth Bader Ginsburg. That was for Halloween. I like to go to concerts. And you can see me here with my partner Colin at Cedar Point in the top right. Roller coasters, thrill seeker. So anyways, I'm Sabrina. I got a major in software engineering from the Milwaukee School of Engineering. I graduated a couple years ago in 2020. I also have a few cats and I make YouTube videos. I watch a lot of YouTube videos. That's probably what I spend the better part of my week doing. Like when I'm not working or sleeping, I'm watching YouTube videos. So I also play the drums. That's more of a recent hobby. Very exciting. And here are some cats. My cats. This is what they look like when I'm working from home. It's ridiculous, to be completely honest, but it's also adorable. So, these are my cats. And enough about me. Now we're going to start talking about software engineering. What is it? Great question. I'm going to use it throughout this presentation as a bit of an umbrella term. Some other words that you might have heard are like computer science and coding and programming and software development. And for the purpose of this presentation, they really mean the same thing. Honestly, outside of this presentation, they kind of mean the same thing. One I want to highlight in particular is computer science because that's what you are most likely to see offered as a degree option at most four-year universities. Some universities offer software engineering in particular. Very few offer both. But for the most part, any university that offers one is going to be pretty much the same thing. So, getting into what those majors even mean. Like, what does software look like out in the real world? So, this is probably not news to you. Software is websites, it's mobile apps, it's video games, it's coding the little stuff that's on your cute little smartwatch. It's using software to like look and manipulate data and use that to do cool things like machine learning and artificial intelligence. Software is used to make robotics move and do the things. It shows up in a lot of different ways and in a lot of ways that you probably use on a regular basis. So the reason, however, though, that we couple software with engineering, it's very intentional. So engineering itself, there we go. Engineering is just problem solving. It's creative problem solving, but it's problem solving in the real world where you have constraints like time and money. You only have so much of each. You have to work within those constraints. And then another piece of engineering, people have been solving problems for a long time now. We look at historical successes. So I've got like a little textbook icon here. You read textbooks to be like, I'm not going to reinvent the wheel. Someone already did that. I'm not going to reinvent this programming language. Someone did that. I'm going to use these to do innovation in the present. So this is really what the meat of engineering is. It is creative problem solving within some constraints, using what you learn, doing cool new things. Very fun. So the engineering process that most people are going to follow here. There's a lot of different graphics online for this. Everyone kind of has a different opinion. This is my favorite because it's simple and there's some implied like iterativeness. Like you can go back through this process several times. So it starts with empathizing with your user. What problems are they experiencing? Now I'm going to define that problem very specifically, ideate solutions for this problem, prototype some of those ideas, test them with those users, and kind of go back through this again. Like see what they think about it, continue empathizing with our users. Maybe we have a different problem that we're going to solve now. It's kind of similar. Try out different prototypes, test different things. This is generically what you're doing when you're engineering. So I think this is best illustrated with some examples. So first, we'll talk about this in the physical world. So let's imagine you are living in San Francisco in the Bay Area, and you're like, there are some absolutely scrumptious bagels across the bay, across the lake. But right now I have to put my car on this big dumb ferry and then get it across the lake. And by the time it gets there, it's been so long that I've already bought food from the hot dog stand on the ferry because it just takes so long. So the problem here is that the ferry's too slow. It's slugging along, not fast enough for me and my bagel habits. So let's think about some ideas. How might we solve this problem? We could build a faster ferry. I mean, the water only moves so fast. I don't know how to manufacture a boat. We could buy more ferries so that you don't have to like wait for a ride. Maybe we could make a magical transport pad. All ideas are good ideas here. Maybe we even make another bagel shop on this side of the lake so that we don't even have to cross the water at all. Or, and I'm just spitballing here, we could make some kind of big water highway. Get the cars from there to there without having to get on this big boat. That's cool. Imagine we're like in a pre-bridge time and this is like revolutionary. Everyone's like, a water highway? Now we're on to something. Now, back in this magical land where we don't have bridges, we do have hot glue. And so we start prototyping and we're like, can we even span a body of water, a gap, if you will? And we find out, yes, if I put some popsicle sticks and hot glue together, we can in fact do that. That's pretty interesting. But does it support any weight? I don't know. I put this example in here just to illustrate like how you might go through this process in the physical world and solving it with like physical things. And let's imagine now you go through this process again and again. Eventually you have a big cool bridge. Now let's go to another example of the digital world. Maybe. So let's imagine this is pre-Netflix and you're like, I want to watch a movie, but I have to get a physical DVD and Walmart's already closed. I don't like any of the DVDs I have and I'm sad. I want to watch a movie, but I don't like any of the ones I have. So I'm bored with my existing movies. This is the problem. And I'm limited by my physical access to stores. So let's come up with some ideas. Maybe we set up like a little free library, but with DVDs instead of books. And maybe we've got like a paper sign up. Maybe we even expand this to be bigger and it's more like a Blockbuster for those of you that know. Maybe another idea is that we could buy all the new movies every month and like let people order them in the mail through some kind of website. That could be cool. Or maybe, I don't know how we'll do this, but we'll license the rights for these new movies. It's probably expensive. Maybe we can do it. And we'll create a website where people can just like view those on their own time whenever they want. That'd be really cool. So we're going to test this out. We don't know if this idea is going to work or if people are going to want to go online for movies. So we're going to buy the rights for like 5 movies, host them on our own server. We all know like a guy or gal that's got a server. And we're going to create a website for people to create accounts so that they can watch those movies. Cool. We'll test this out with our close friends and family. We're not super confident in it yet. We don't know if our favorite gal server is going to support hundreds and hundreds of people looking at these movies. We got to test it out. Let's say this test goes pretty well. Now we start to expand to the people that are using it. We say, we're going to incentivize you to share this around. More and more people are using this. Eventually we have Netflix. We're going to build this to be more robust. And all of a sudden it's like the top streaming platform in the world. Crazy. So I give you these 2 examples to illustrate that software is merely a tool for solving problems, the same way that like wood and metal and like hammers are used to build a bridge. We use tools like software to build websites and things to solve problems in like a digital space. So you might still be wondering though, like Sabrina, let me make my face bigger. What is software? Like you're talking about this, like we're supposed to know like what a website is. I'll tell you. First, we'll start with an example of a game. So this little snippet here on the right is in Scratch. Scratch is a drag and drop programming language. So you can imagine that I could click on any of these like orange or yellow or blue boxes and drag them anywhere I want in whatever order. And then Scratch, because I'm doing this in Scratch's website and in Scratch's like game builder, they know how to interpret these code blocks. And it says, okay, when you hit start, when I receive play game, then forever I will keep looping through this if statement. And if the player is touching the target, then I'll change the score by 2. Cool. So we can imagine this player is like controlled by arrow keys. Maybe this target is moving around the box and the player has to chase it. And this is the game. Pretty straightforward. The thing that starts to bring programs to another level of complexity is actually kind of simple in its core. It's this kind of boring if then, if else. And so this is a really simple example just to say like, if x equals 4, then say x is 4. And if that's not true, then say x is not 4. Very, very simple. But these kind of things enable us to start having different behaviors in a program. Like if we go back to our game example, now we can imagine there's a second target. Maybe that target's red and it's moving a little bit faster and the size is a little smaller. And so we can say if touching the blue target, then change score by 2. Else if touching the red target, change the score by 4. That's a bigger accomplishment. And now we've got a little bit more of a complex game with these kind of simple things. So the next example I'll give you is more visual, and that'll be with this example of mobile app development. So you can see here we have the Facebook mobile app on both iPhones and Android phones, and for the most part they look the same, right? These are effectively the same app, minor differences. However, on the back end, these are built in completely different languages. So languages are our next concept here in software, where you're able to use different ways to write things as means of creating the same thing. So both of these examples create a button. On the left here, we can see in Swift, this is for developing iOS apps. You define the button at the top. You say, this is what the frame is going to look like, the background color, this is what the title of the button will be. And then this part on the bottom here is saying, we're going to assign it this action so that when it's clicked, this is what's going to happen. And there's this concept of a self here that we can see in a few places. And this, oops, excuse me, knocked my clock down. So this is how we build a button in an iOS app. Then on the right here, this is also building a button, but in an Android app. And this we can see is actually split into 2 different files. In the first one, we have what the button looks like, and then in the second, we have what the button does. These are 2 completely different approaches to programming, but they both result in like basically the same thing. And so I put this in here to illustrate that software is built in different languages, and there are different languages that are better or more optimized for different scenarios. For example, mobile apps require languages that are able to compile on each of those respective devices. So an iOS device only really knows how to interpret that Swift code that we saw on the left, whereas an Android device only knows how to interpret that stuff on the right. Similarly, there are languages that are like optimized for video game development. And it's not a language I would use to write a web app or a mobile app, but they're really, really good for building video games. And they all work differently. But they're all kind of similar. They're similar to the core of like, it is logic and things like happening in a sequence and doing different things based on other things that are true. So I mentioned a little bit that only like an Android app or an Android phone knows how to understand that Android code. So we can see here that there's this element of magic happening. It's not really magic. At some point in my education career, I could tell you exactly what this compiler does. At this point, I can just kind of rely on it doing what it does, and I don't really have to worry about it. And for the intents of understanding what programming is, we can kind of treat it like magic in that like it knows what this XML and Java code is, this Android code, Like it will take that code and the Android compiler says, that's beautiful. I love this. You're speaking my language and I can give you this Android app on the other side. And then similarly for an iOS app, if you give it the Swift code that the iOS compiler knows what to do with, it says, cool, I'm going to give you this iOS app. And you'll be able to use this on an iPhone. An iOS compiler would not be able to interpret the XML and the Java code because that's not what it does. It knows how to do the iOS stuff. That's its job. It's good at that. And so you can imagine this expanded into like websites and games and things like that. The compiler is really the magic that says, when I write button blah, 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 does this, this, and that, and the other, and this screen with all these pages and all these boxes of text, the compiler is what knows what to do with that and is able to display that. So to quickly recap, because we kind of went through a lot just now. Engineering is problem solving. We got that. That's pretty clear. And then to be a software engineer is to write software in different languages to solve problems and create products. So we use this software that we're learning in order to solve problems. Software is our tool. So now we've gone over these first two goals. I'm going to start explaining how to get into it. We're going to build a little bit on our understanding of software throughout the rest of the presentation, but I want to start getting into like, now you've got an understanding of what it means to build software, and now how might you pursue a career in this? And how do you really become a software engineer? And this is exciting. It's time to start talking about me. Ha ha ha. So, I was first introduced to programming in this web page design class that I took in high school. So, when I took this class, it was really just, I had to fill an elective, and this one sounded interesting. I was like, I spend time on the internet, web pages. Yeah, cool. Let's try this out. And so, I ended up liking it well enough. It was a pretty simple class. Like I think my final project was like a dog website because I couldn't be bothered to be more creative than that, apparently. And so I took this class and it was whatever. I ended up then in the summer between my junior and senior year, I was getting bombarded by colleges and universities in my email. They were like, come to our university, give us your money, please. And one of them that was particularly noisy was the Milwaukee School of Engineering, which I will refer to as MSOE now. So I end up giving in to their persistent emailing, and I go on a tour there, and the people who are employed in the admissions office here, give them a raise. They're doing a great job because they convinced me. They're like, you're so smart. Smart people like you belong here at MSOE, and you're so smart. Like, we can't wait to have you as a student here. And at this point, I'm like, okay, true. And I knew that engineers made a lot of money, and this was a school of engineering. And I was like, okay, I'm liking this. I'm smart. I'm going to make a lot of money. Very cool, very cool. And I ended up applying to the university like on the spot. Their application's like notoriously fast, and you don't have to write an essay or anything. And so I apply on the spot, and upon applying, they have you choose your major. And I was like, I don't know what I want to do. And so I ended up selecting software engineering because I was like, computers, like I use computers. I'm on YouTube. I'm on Club Penguin. Like I'm using computers. And engineers, I want to do the engineering thing because, like I said, engineers make a lot of money and I want to do that. So what else is there to talk about? And so I picked my major, and then during my senior year of high school, I take a couple programming classes. I'm like, maybe I should prepare myself, see what I'm getting into. And so I take intro to programming, and we're doing that drag and drop programming that I showed you earlier in Scratch, and taking AP Computer Science. This is where I learned my first like official language. I learned Java. And at this point, I want to make it clear that like I have no idea what I'm doing. Like I had just started to dip my toe into learning how to code and understanding what software is. And I'm like, what's going on here? This is not quite yet my forte, to say the least. And so despite all that, I ended up doing this like quote unquote internship at one of my friend's startups. This friend was like my soccer coach at the time. And he was like, oh, you're going to go to school for software? Like come work at our startup and like do software development, like get some experience on your resume. I was like, that makes sense. But when I reflect on this experience, it's like a little pathetic because like I said, very little experience at this point. Like I don't really know what I'm doing. And they at the startup are building an Android app. And like all I did was add, I think I put the company's logo on all the pages. And like that was my outcome of this summer, was that I had put an image on all the pages. And I was like, wow, that was tough. And it was, because there's very much like a slow burn of learning how to code. It's, at least for me, software was not something that like came naturally to me. When I knew that I wanted to go into engineering, I knew that engineers were good at math, and I was good at math. I was like, I love math. I'm good at math. And math just like came very naturally to me. But like software, I thought they would translate. Not the case. Software did not come naturally to me. And so I had a very unclear vision of like what I was looking for and what I wanted, besides that I knew there were things I was good at, and I knew that I wanted to make money. Like I didn't want to be poor. And so eventually I get into college, right? Flying by the seat of my pants completely. I'm getting my degree in software engineering, as you can see. And I start to feel like, like I'm not like the other people here. Not in like a, I mean, it was like, I'm not like other software engineers, but I was like, my peers here, they're like so passionate about software and they're so good at it. And it seems like these other people, like it just comes naturally to them. And this just is not coming naturally to me. And I don't feel like I'm good enough. And I don't feel like I have enough like care about learning software well to fit in here. I don't feel like I belong. And this was tough. Like during my freshman year, this was kind of like ruminating in the background the whole time. And I was like, I don't know if software is right for me. So eventually I do this thing in the third bullet, the commons. And this is very like startup vibes. This is startup round 2. And so I am like bringing this idea into this skills accelerator, an idea for an app. And I'm working with a team of other people from other universities, and we're going through that whole process that I illustrated earlier, the engineering process, where we're like empathizing with our user, we're defining really clearly what their problem is, we're coming up with ideas and solutions, yada, yada, so on, so on, so forth. And I loved it. I loved like going through the whole process. Whereas up to this point, I felt like my degree was living in that fourth circle, the prototyping phase, the green one, where I'm only building the solution, but I was like, I like everything else. I like coming up with the solution and understanding what the user is experiencing. And this kind of built on my feeling like, I don't know if pursuing this degree is right for me. And honestly, if I had been at a different university, I might have switched majors at this point. But MSUE only had like engineering majors, as well as like nursing and like business and math. And I was like, I don't know if I really want to do any of those. And so I ended up, there we go, sticking with software engineering. And maybe that's not a surprise because I'm here talking to you about it today. But I stuck with it because I started to understand a few different things. I was like, software, I think, will be a good foundation for my future learning and career, because it's a skill that I can get pretty good at, but I don't really need to be passionate about it to be good enough at it. I also don't need to be the best at it to be good enough at it. Like I'm a good software engineer, but I didn't put 100% of my time into being like an extraordinary coder. I put my time into being like a good teammate and a good leader and a good communicator, as well as being like a decent software engineer. So I know how to code and I'm like confident in my ability to like produce software, but I started to put my time into things like clubs and other leadership opportunities so that I could become like a more well-rounded individual. And something else I noticed here, amongst doing the internship at the startup and doing the commons, which was like very startup-y vibes, I was starting to get this understanding that there was a world outside of just getting this degree, going to work at some like big corporation full time, and then like retiring and like working there till I die, basically, right? And I was like, there's this alternative reality where I could like come up with an idea, build my own company around it, and like live a different lifestyle. And then there's a lot of things in between that. Like these aren't the only two options, not just like corporate and startup, but there's a whole slew of options in between there that is like smaller businesses and consulting and what have you. And so this is all to say that toward the end of my freshman year, I was having this existential crisis, and I decided, you know what? I'm going to treat software like a tool, because it is. I'm like coming to this understanding, and I'm like, I will get good at using this tool, but it's okay that I'm not passionate about this hammer. I don't have to be in order to use it well. So, post-university, I eventually graduate, I get my degree, whatever, and I try another startup idea. It doesn't really work out. At this point, I'm working full-time for some big corporation. I ended up exactly where I didn't think I was going to end up, which is kind of fun, but it was a pandemic. They offered me a job. I had a good time there. It was fine. But as I mentioned earlier, what I was worried about was that I was going to only live in this like green circle in the prototyping space where all I'm doing is like executing. There are other people involved who are doing all the fun stuff in my eyes, which is like talking to customers, understanding what their problem is, and like coming up with solutions and testing it with those customers. All I was doing is building what people were telling me to build. And I didn't think that was very fun. So eventually another company reaches out to me, Rockin' Cat, which is where I work now. And it's like an agency style company where other companies will hire Rockin' Cat in order to build their products, their software products. And so when Rockin' Cat reached out to me, I was like, I am ready to jump ship. I am sick of just code monkeying and like building what people are telling me to build. I want to be more involved in the process. And so now I am. Now I get to put on my like designer hat and say, this is what it's going to look like. This is what I think we should build. I get to put on my product manager hat and say like, this is what's important to our users. And this is how we're going to solve their problem effectively. And I get to participate in all these different phases of the engineering process, which is just way more fun, in my opinion. And software has been like the platform on which I've springboarded myself into being able to like get this first job and then get this now second job and move into a space where I actually am more happy. And now that I'm happier, I get to pursue hobbies and things. Isn't that fun? We love that for me. So, to recap, that was kind of a lot. So, your major doesn't have to be your passion. It can totally be a means to an end, but you do have to be able to like tolerate it. Like I can tolerate coding for several hours a day, and it's fine. It's like fun enough. It's not my be all end all favorite activity, but I have a good enough time to do it for a living. Additionally, you don't have to be the best to be good enough. You can be a perfectly good engineer without being the top of your class or putting all of your hours of all your days into being a good engineer. Thirdly, being a good teammate is just as valuable as being a good programmer. Programming is very much a team sport, or I should say software engineering is very much a team sport. Anytime you go to like work in another company, you're going to be working with other software engineers. You'll be working with people who are designing what you're building, who are like helping you understand like what you're going to build. And it's really, really important to have like strong communication skills. And I'll get into that a little bit later. But this all adds up to being like a well-rounded person. And that's what I think makes you a great engineer, being able to do well at the minutia that is like software development, but as well being able to see the big picture and like work with a team and communicate in order to build these products. It's not as simple as like, I code this button and you code this screen. There's lots of interaction there. And then lastly, there are many phases to software engineering, and you don't have to live in just one. You can. Some people love that. They love like being told what to build, and then they build it to the best of their ability and they output it. And they're like, this is good. This is good for me. That's not my journey, but it could be yours. So now let's say you're listening to all this and you're like, yeah, I'm interested. I would consider pursuing this. There are a few different options, and we'll get into all of these. The first one is a bachelor's degree. This is obviously what I got. So I'm biased a little bit here as this is the decision I made. And I enjoyed myself. I think there are a lot of good pros to getting like a 4-year degree from university. One of them being that there are career resources. So our university had career fairs and a career services department. There's lots of different opportunities for mentorship from your professors and other people to help you get a job, which is ultimately the goal of university, is like, I learn to do this thing well so that I can get a job and like be employed, because we live in a capitalism, am I right? So the money is what enables us to do other things. So career resources are really valuable at a 4-year university. As well, There are different software related resources like your professors, your classmates. Sometimes an institution will have different resources like a supercomputer that make it better, easier, more fun to learn software. Another thing is that, as I mentioned with career resources, you're more likely to get employment out of completing a degree program. It'll be a little bit harder to do that when you choose some of these other options, which I'll get into. But this is like the highest likelihood to say, like, when I graduate from this university, I'm probably going to get a job. Another thing is that it's very guided. There's a lot of hand holding. This could also depend on the university you're in, but for the most part, they'll have like a curriculum that you go through, and there are professors and your classmates and everyone to like help move you through. There are lots of people who have a stake in your success. They want you to be successful. And this was something that was really valuable for me, because as we get into the other options, like, for example, being self-taught, I could not have taught myself software engineering. That would not have been good. That's just not how I learn. That's not like, I wouldn't have had the ambition to like push through, to be completely honest. That's just not for me. The last thing that is nice about like going to a big 4-year university, or not necessarily big, but like where it is a university, there's like a campus culture. You get that kind of college experience where you are learning from other people, you're meeting other people, doing fun things, doing stupid things. Like, there's some value in it, in that like you don't expect to come into a university at 18 like knowing exactly what you want, and the environment that a college creates kind of helps you move through that and start to understand like who you are and what you want. That being said, like, this is a luxury. It is a luxury to pay for this, which is our first con, is that universities are expensive. For some people, it's simply a bad investment. Like, you can simply not afford to go to college, or you simply can't afford to like take on the student debt that it would take and then be able to pay that back in order to like get this kind of opportunity to learn and fail and try again. Another thing is that it takes a long time. Most degree programs are slated to last 4 years. Some people do what we like to call a victory lap, where they go for a 5th year to complete their degree. Some people do a couple of those. It is what it is. But it takes a long time because there's a lot of classes that you're slated to learn. And because of that, changing your mind can be kind of costly. Like, if you choose to switch majors, it could mean that you're like starting not from square one, but square two maybe. And you have to stay a little bit longer, do a couple victory laps in order to complete your other degree. And the last thing is that the curriculum can be kind of rigid, in that you don't have a ton of flexibility in what you're learning. And so, for example, I ended up in a place with my software degree where there are a handful of classes that I had to take in order to graduate, but I was like, I don't like this. I don't think I'm ever going to use this, but I have to pass it in order to like finish and get my degree. And sometimes that just is what it is. And some of those classes now have proved to be valuable, blah, 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 whatever. But you don't have the most flexibility of all the options I'm going to present to you in a bachelor's degree. So next, we have an associate's degree, or like a minor. So an associate's degree implies 2 years usually, and a minor could be any number of classes that will like supplement another major that you choose. So this is still in the college sphere. And pro to getting an associate's degree or a minor is that this is going to be cheaper. This is going to be shorter than a bachelor's degree. And you can couple this with another degree or like another skill or experience you have. And this is where the meat of value is here in getting like a minor or an associate's degree, is like, let's say that you have work experience in like a manufacturing facility or in like a shipping place. There are companies who are producing software in that industry, like in manufacturing and shipping. And so your experience in those industries, coupled with now your ability to program a little bit, like, because you're doing this associate's degree, your minor, you're learning to program, coupled with those two things, you become, uber valuable. Because this company's like, we don't have to teach you about the industry. We don't have to get you on the same page. And you can even bring knowledge to us that like we don't presently have about the way this industry works. And so that is, I think, a really fun reason, or a really like valuable reason to choose to do like an associate's degree or a minor, because then you look like the super smart person who knows how to code and also knows how this industry works. So that is an option. The next option is a coding bootcamp. So these have become more popular in recent years. Essentially what this looks like is like a 10-week full-time, and often these coding boot camps will have like a repayment plan. So once you finally get hired, then you pay them some amount of your salary in order to pay for the boot camp that you've already taken, but you don't have to pay up front. And that's really cool because 10 weeks obviously is shorter than a 4-year degree. That's nice. They're not all 10 weeks, but this is just an example. And they're explicitly preparing you for a job in software. There's no like math and English classes that you have to take. It's exclusively software knowledge. So similar to the associate's degree, you can easily couple this with like another degree or an experience and do this kind of in your own time. Like you could take a couple months off from work if you're able to afford that and like do this boot camp. And this is still a guided education and handholding. As I've illustrated in this bullet, it's still like lectures, assignments, individual projects, and group projects. Like you're doing kind of school, but it's in a setting outside of the university. The cons of this is that you have less time to learn and intake. As I described earlier, learning software, at least for me, was kind of like a slow burn. And I eventually like started to build my understanding better and was able to learn better once I had like a stronger foundation of an understanding of software. And if I had less time to do that, it might just feel too fast for me. Another thing is that some jobs require you to have a degree in order to apply. I put require in quotes here because some jobs will filter you out right away. Other jobs will still interview you and whatnot. So they like say they require it, but they really just do that to like filter people out. It's absolutely a bias, and people have different opinions about whether or not this is like fair or ethical to like require people to be degreed in order to apply for their jobs. I put this in here just to illustrate that like it's not great, but it is something that you will encounter if you do like a coding boot camp, or if in the next slide you are self-taught and you don't have a bachelor's degree. It's going to be like a little bit harder in order for you to actually get the job. Like you absolutely can. People do it all the time, but it's not going to be as simple as showing up and saying, I have a degree, and they say, cool, we believe you. We like believe you know how to program. It'll just be a little harder to demonstrate your abilities. The last thing I'll say about coding boot camps, and I put it in the cons here, is that sometimes these repayment plans can be a little bit predatory, and sometimes they like require you to do free labor for the code camp itself. This isn't often like super detrimental, but it is something to look out for if you do choose to pursue this option. Just look at what those repayment practices are and look at reviews for the code camp to see what people who have graduated from it think about it. Okay, lastly, you could be a self-taught software engineer. Now, let me be clear about this. This is vague, but people do this all the time. Some people are just built different. When I say built different, they're built differently than me. I could not teach myself how to program. I really needed the like guidance and the mentorship and the hand-holding in order to learn this. But sometimes whatever you are, like sometimes this could be a good option for you because you're able to learn at your own pace, like learn exactly what you want. It's going to be much cheaper than any degree you go for or any like coding boot camp because you might just have to pay for a few online courses here and there. There's a lot of free resources, and you can easily do this in your spare time. You don't have to like dedicate your full-time life to this. You could work full-time. You could work 2 full-time jobs and start learning programming on the side, because truly, like, not everybody can afford to just like pay for college or take on the risk of student loans. That's totally okay. Like, you might need money immediately. You might already be working, and so you're like, I need to continue my full-time job after I graduate high school because I need money. Like, I need to live. And so this is a route that is more accommodating if you already have to like work another job. The cons to this, as I started to get into, is that there's no really built-in guidance or mentorship. There are communities that you can join online for other people who are learning to program and learning to code. There's lots of YouTubers and other content creators who are creating good content for this, but no one is holding your hand. There's not the same amount of people who like have a stake in your success. And then similarly to the coding bootcamp, some jobs will require you to have a bachelor's degree. It'll be harder for you to prove that you like know what you're doing. The other thing is, in my case, like taking out student loans was the right choice. And so I was able to like take on some risk and take out student loans so that I could pursue my education and like afford to live while I was in school. You can't take out student loans to like self-teach yourself. So this is outside of like, I need to work full time in order to sustain myself. You might be in a boat where you can take out loans and afford to take that risk, but like the government's not going to give you money for you to say, I'm going to self-teach myself at a program. So yeah. So these are the 4 options. There might be more, but these are the ones that I understand. And so in order to figure out what's for you, there's a lot of research to be done here, but maybe even me explaining this, you've decided like, oh, I definitely need handholding, or like, handholding is not for me. I want to like just learn this on my own. This is very much an individual decision, and don't let anybody shame you for picking one or the other. I think there's like very much an elitism that exists within software engineering, and people who, like me, are biased by having thrown thousands of dollars into their bachelor's degree. I would love for there to be some like magical reason that makes me a better software engineer than someone who's self-taught, but that's just honestly not the case. Like, there are plenty of self-taught engineers who are and like will always be much better engineers than I am, or much engineers than I've ever met who like went to school with me. None of these options like inherently makes you a better or worse engineer. It's kind of like what you get into it, what you put out, like, and choose the option that's right for you. So, into our last point. I've got some loose, just kind of other things to show you that might help you answer this, like, how do I know if this is right for me? I know what this is now. I know like how I could pursue it. What else is there to consider? So I'm going to explain some examples of like what the day-to-day of software engineering looks like and what it looks like to do the work. So if we go back to our Facebook example and we imagine Facebook is a huge company, right? Like, they provide Facebook as an app on iPhones, Android phones, and on the web, on the websites. So they have teams of developers who know that language, right, to like talk with that device, and they're working together to make the iOS app. The Android developers are working together to make the Android app, so on and so forth. And all of these developers are, wrong way. They're talking to product managers and designers. The product managers are the ones who are talking to customers. They're creating the kind of list of the work that needs to be done and deciding like what's important, what needs to happen first, so on and so forth. And that gets disseminated down to the developers. And similarly, the designers, once they know what work needs to be done, they're the ones, they've gone to school maybe for graphic design, and they're making little cute mock-ups of like what the screens are going to look like, and they give that to you, the developer, and now it's your job to take that screenshot and say like, this is what it's going to look like now, or this is how I'm actually going to make this happen. Further, let me drag my little face down. In a big engineering company like Facebook, they also have leaders and C-suite people at the top, like CEOs, what have you, who are envisioning like the big company strategy, and they are making these more vague statements like, we envision a world where communities are even stronger online. Part of that is we think it's important for users to be able to move seamlessly between mobile and web. And this is like the direction that we want to take the company. And so the people at the top, the leaders, are saying these kind of things that they think are important. And then it's up to the product managers to say, here's exactly what it looks like to achieve that vision of being able to move seamlessly between mobile and web. And then the designers design the stuff, and then the developers execute. They implement exactly what everyone has decided is important. And so this is an example of what it looks like at like a larger organization. Earlier when I was describing the process of engineering and how like this is one of those worlds where like developers are only living in that prototype phase, right? So, oh good, I did put the visual here. So there are tons of different people. Like, Facebook is a huge organization. There's hundreds and hundreds and hundreds, maybe thousands of people who are involved in this process from start to finish, and developers are mostly living in this green circle here. So that is a lot to coordinate, and so big companies will tend to use Scrum, which is a particular process. It's kind of like we've made this list. This is a big graphic, but it's like we've made this list of like things that you do in order to like effectively create a software product, and you go and do these things, and part of doing this makes you a better functioning organization. And so that's pretty vague, but I'll get into it. So at the beginning in the top left here, there's some vision. Like you say, we want users to be able to move seamlessly between mobile and web, that it's like a similar experience visually. And so then someone creates user stories. They say like, as a mom of 3, I want to be able to continue my Facebook Messenger conversation on my phone when I inevitably have to like go tend to my child. I like have to step away from my computer and go tend to my child. So I want to be able to seamlessly use Messenger between those platforms. And so then someone else will come in and say, okay, here's exactly what those tasks involve. So we need to make sure that Messenger is available on both of those platforms. We need to make sure that Messenger is like updating in real time so that if I started drafting a message on my laptop, maybe I have access to that draft on my phone once I walk away. And so there's a backlog of work that's created. And then you go through the sprint planning, which is a meeting. You can see that in the kind of bottom left over here. And then you decide, okay, for the next 2 weeks, we're going to commit to doing like these few tasks. And during this 2 weeks, you're meeting with your team daily, talking about what's going on, what you need help with. And then ultimately at the end of the sprint, you have delivered some new functionality. You present that to the team and everybody else who's involved in this. Eventually that gets rolled out to users, you get feedback, so on and so forth. If there's issues with what you've rolled out, a new task gets added to the backlog, the product backlog, and this is how you develop software. And so the thing that I want to point out here is that there's a lot of meetings. You're doing a lot of coordinating with other people and working with other people and talking to them. And so people skills are going to be super, super useful here because, as I've said earlier, software development is a team sport, very rarely done by yourself. And if you are like that person who's like, well, I'm a super good software developer, like I make really good code, but I can't work with other people, like people don't want to work with you. You're not going to keep your job because at some point being able to work in a team and like work together becomes more important than being able to like write code effectively. You need to be able to do both. You can't just do one or the other and expect to skirt by. So this is an example of what it looks like in like a really, really big organization where there's a lot of coordination that needs to happen all the time because there's so many people, there's so many moving parts, there's so much work to do. Facebook's a big company. They have a lot of apps to support. So, you know what? I reworked this slideshow a few times and I don't think this necessarily fits here. So we're going to skip past it. So now I want to give you an example of like what it looks like in my current job to do work. I explained earlier how like you will use, like someone will design what you're building and then it's your job to build it. We can imagine like I'm building chat into an app that we have. And so it doesn't currently have any chat in it. So I need to add that. So here's like a screenshot that I can start with for what I should be building and what it should look like. So the work that needs to be done here is outlining what needs to be done first, because this is a lot. And then I have to pick where to start doing it, do some stuff, reevaluate, do some more stuff. These first 2 bullets that I've got here, it's kind of where the real hard work of software engineering happens, because it is not simple to just say like, I will just make that. You have to choose somewhere to start and like outline the work. And so in this next slide, I think I started to do that. Yeah. So it's like, okay, I need a page for this to exist on. Like that's a place to start. So I need a page that I can start putting buttons and like inputs and date headers and stuff like that on. Then maybe I decide like, okay, this date header seems pretty simple. I'm going to create that first. So I'm going to write my lines of code to like make 2 lines and then display the date in this particular format. And now that task is done. And now next I'm going to do the message piece. So I need a blue box and I need to put the text in white and I need to grab the text from somewhere. And so maybe the way that I approach this is to choose to like do all that visual stuff and say like, I'm going to give it some fake data, like a fake message. I'm going to type it out myself. And then after I've decided like how it's going to look and how I'm going to make it look that way, then I can connect it to real data from wherever we're storing the messages. And so this might sound a little confusing, and that's because it is. What I'm trying to explain is like deciding how to execute stuff is difficult. That is part of what you're learning in whatever education route you choose, is like how to do the work and how to figure out what needs to be done. So as much as I was like talking smack about only living in this prototyping sphere, it is hard. Like this prototyping sphere is hard work and it's challenging, and there's lots of complexity here because, as I was trying to illustrate, like it's not as simple as just making this screen. You have to choose where to start, choose what to do next, choose how to make all this happen. And that's what your experience is as a software engineer. So there's this saying that I've heard a handful of times, and we'll just ignore this other stuff back here. But one of my coworkers at an old job explained this to me when I was like, man, I'm having a hard time starting this task because I don't know where to start. He would say, how do you eat an elephant? One bite at a time. It's a big, big thing to do. So you don't just eat the whole elephant all at once. You have to like find bite-sized pieces and like chew those off one at a time. And that's what I started to illustrate here, which is picking these little bite-sized chunks and tackling it a little bit at a time. And this, I don't know if I've hammered this home enough, like this is the hard part. When I was starting my software degree, as our projects got more complex, like at first it was something simple like, okay, like maybe when we started doing visual stuff, it was like make a box, put a triangle here, put a square there, put a circle there. And you're like, okay, this is very clear. It feels like I can extrapolate this into tasks very easily. But then the next task or the next project might be to make a calculator. And so then you say, well, should I start by putting the buttons all in the right spot? Or should I start by doing like the logic that will make addition and multiplication happen? Should I, like, where do I start? And then you start to have this like decision making, and you might make a decision, realize it was the wrong decision later, learn more about what you're doing, and then you reevaluate and you change things up. You might restructure some stuff. Maybe you even start over. I've done that many a times where like I took one approach into solving this problem and like starting to do this thing, and then I'm like, never mind. Now that I've done this, I've learned some more about the problem I'm solving, and this is not the right choice anymore. So I'm going to start over. And this is like what makes software engineering hard. It's like what makes engineering hard in the first place, because you might do a similar thing with a bridge where you're like, I'm going to build the bridge in this direction with like this amount of wood at these angles, and then all of a sudden you're like, the bridge fell. Like I can't do anything about that. Now the bridge fell. So clearly what we're doing is not going to work. And so you have to start over and reevaluate. And that's like the hard part. So now I'll move into some more like general advice and final thoughts. So I asked for advice from my coworkers. This was something my coworker Matt said. He gave the example of like, if you love the idea of having a book, but you struggle with writing, then you should probably not go into creative writing. Because I think like many of us, we would love to have a book. That'd be very cool. But like, I don't personally like sitting down to write for hours at a time. That's not my jam. So I'm not going to go into creative writing. So similarly, if you want to build a piece of software, like it sounds cool to have an app, but you don't enjoy the process of writing code, then you're not going to end up ever building that app, because like you can't be bothered to like spend the time putting into it. And instead maybe consider like going into product development or business, because you like other parts of the process, but you don't like the process of coding. Now, you might be thinking, Sabrina, this sounds like you. This sounds like you didn't love the process of coding and you liked all that other stuff. Why didn't you take this advice and go into business? And like I said, if I was at a different university, I might have taken this advice. I might have switched my major and jumped into something totally different. But I do believe that like you can use software and like the the task that you don't love doing, you can use that as a stepping stone to get into these other positions and these other parts of the process. But you do have to be able to stand to do this thing for like hours at a time. Because the reality is still that like I spend several hours a week coding. Like fingers on the keyboard, I am making like web applications. That is my job. Like I am paid to do that, and that's what I do. And I can stand to do that. And this sounds like a little negative to just say that I could tolerate to do my job. But the reality is like I said, software is the tool, and I don't need to be passionate about it to effectively use it. Like I don't need to be passionate about a hammer to make a bridge, or to like, maybe I'm a welder and I love the process of building this like cool thing, but I'm not like in love with like the actual soldering. I think that that's completely okay. But if you are like doing coding and you're like, I absolutely hate this, like I can't stand to do this, then like pick a different major. That's fine. Like as much as I'm hyping software engineering up, and I will continue to hype software engineering up in these coming slides, sometimes it's just like, it's not for you. You're like, I simply don't like doing this, and I don't want to do this. Like, you couldn't pay me enough money to do this. In my case, you could totally pay me enough money to do this, and people do that right now. And that's fine. So this kind of highlights what I talked about earlier with the associate's degree. So this is another piece of advice from my coworker, Jason. He wished he had known that like software would be so pivotal and that you can write software in any area. And if you have skills and experience in another area outside of software, and then you know how to code, you become like super, super valuable. You look like a super genius because the people around you who also know that area don't know how to code, and you do. So yeah, so software is like a useful skill anywhere. You can use it, like I said, as a stepping stone to get into an industry that you actually care about or solve problems that you actually care about. What I have put this slide in here to say is like what some of these careers look like. So I already went over mobile development. So like maybe you work at Facebook, or you work for some company in your backyard being like your local city, where they want to make an app and you're like, I can make an app for you. Similar thing for web development. Software also powers like augmented reality and virtual reality. So I hate to keep using Facebook as an example, but they have the Oculus for virtual reality, and that is software that is being used to power that and do the games in there. I've made these two buckets for software engineering and computer science because software engineering tends to be more product oriented and dare I say like more engineering focused, where you're like, we're solving problems for people. Whereas computer science starts to lean into more of the scientific world, oddly enough, where you might be solving problems more in the scope of like a scientific hypothesis, where you say like, I want to hypothesize that like this particular piece of data is something that we can use to infer this outcome. And so you use like software to parse through lots of data to see if like when you align those things. Do you know what I'm getting at? Like when you say like correlation causations, you say like the amount of people who buy ice cream affects like the number of murders that are happening in this area or something. That's an example of like correlation does not equal causation, but you use software in order to like parse large amounts of data to like make those visuals and make those interpretations. And then that kind of goes further into machine learning and artificial intelligence, more complex like understandings of that data and processing that data to understand different things. So that falls more into the computer science sphere. Like I said, when you get a degree, like a 4-year bachelor's degree in software engineering or computer science, they're pretty much the same. One difference that you might find between those programs is that computer science will set you up better to get like a continued education or like graduate degrees in computer science and learning more of like what will help you do scientific research, versus software engineering is usually a bachelor's degree that's expected to kind of sit on its own and prepares you for work in the sense that you will like go and be able to develop products for companies or for yourself or what have you. The third bucket that I put on the left side here is embedded systems. And this is a new word, I know. Embedded systems is software, but it's software for hardware, where hardware is like your physical computer or like a physical robot, or it's the idea that like you're writing code that decides how things like physically occur. And so this starts to breach into that space between digital and physical. And this is honestly not my cup of tea. The languages that you use to do embedded systems work are different. You have to like worry about memory, which I'm apprehensive to start explaining this because the rabbit hole gets very deep very quickly. But for the most part, when I'm like developing a web app, I don't have to worry much about the amount of memory I'm using or the amount of times I'm like making a call to like another website or something like that, because it's not that costly. But for embedded systems, when you only have like one physical chip that only has so much room to store stuff, a chip being like what powers a computer or like what powers a phone or something, you only have so much memory there. So you have to code much more like thoughtfully and carefully in order to make the best use of the amount of space that you have to store things. Like now storing numbers and storing information becomes like much more costly. So you can't simply store all the information because you only have so much. And so that probably sounds a little ambiguous. It's because I don't really like it. Like making all those considerations for me is not exciting or fun, but I have a handful of friends who like that is their jam. They love that. And so that's worth exploring. Some majors that you might see in that space are more like computer engineering and electrical engineering. Worth exploring. All those are offered at MSUE. Very cool. And then in this other column, this column on the right, I decided to list a few careers that are software adjacent. So while I've been explaining this presentation and explaining the engineering process again and again and again, I mentioned that there are lots of people who are involved in that process in different spaces. And so some careers that line up a lot and are like really close and work heavily with people who like do software engineering, like me, are people who have studied like user experience and UI design. So they're people who have put time into learning how to build screens such that they're like the most usable they can possibly be, like very usable, very beautiful, very easy to work with. Similar like to graphic design, graphic designers are learning how to make like beautiful digital creations. Maybe they're the ones that are making like the beautiful graphics that are like smooth when you scroll down your phone. And so those are adjacent to software. Perhaps those are more exciting to you. You can major in exclusively these things and you don't even have to like touch software. These next two bullets, like product management and project management. Product management is people who care more about like what is the most important thing to build right now and how are we going to address the needs of our users. And they might do more of deciding like what is the solution and what's going to be built. Whereas project managers are often more process oriented in that they're saying, this is the task that's in front of us. Like, here's how we're going to tackle it. Here's like the people that are going to work on this. Here is like when we're going to deliver stuff. What can I do to make this easier for you? It's very process oriented. And so there are project managers in industries across the world. Like, it's not just software. You could be a project manager for a manufacturing facility or for like cannabis distribution. Like, it could be anything. And then what I've listed here, like what I was just talking about with embedded systems, computer engineering and electrical engineering. Those are more like hardware focused. So if you really like if you're one of those people who's like taking apart your computer and put it all back together, I always thought I was going to do that. That's not my jam. I don't like that, but some people do. And so if you really, really like the physical components and like working with robots and things like that, then computer engineering or electrical engineering might be more your speed. Okay. It's been a long time. It's been an hour, but we're getting into it. So lastly, things that I think make a good software engineer, these all kind of operate around the like team player attitude, that you having humility is really, really important because there's so much that you don't know and there's so much to learn all the time that being able to admit when you don't know something and that you need help is really, really, really crucial. This is something that I'm admittedly not great at and I'm like continuing to get better at. but it's really important because you spend a lot of time being like the least experienced person in the room. And so putting your ego aside to say like, you know better than me, I would love to learn from you, is super, super valuable. Next, being a team player. Like I said, engineering is a team sport. Strengthening your communication, being honest, having compassion for your teammates, very important. Having a drive to learn, as I started to explain, like things are changing all the time. There's always more stuff to learn. There's like a new language or a new way to use that language in order to do a different thing. And there's just always more to learn. And so you will honestly just constantly be learning as part of like being successful at your job. And so having that curiosity and that humility to say like, I'm not the best at this, but I would like to become well versed in this is nice and important. And then lastly, being a problem solver. As I said, engineering is problem solving. And as I was trying to describe earlier, the work is like, even once you get to the point where you have a login page and you're like, I just need to make a login page, figuring out how to actually do that is another problem to solve. It's another task to accomplish. And so you're constantly problem solving, learning all the time, and working with your team. Now we'll get to kind of the fun stuff, which is the perks of having a career in software engineering. Perhaps I should have started with this, but I'm assuming if you're watching this presentation that you already have an interest in this and you've maybe heard some of these things. For example, that software is a very high paying industry. It's also very stable. It's going to be around for a long time. Like if you get a job, it's not likely to disappear. It is likely that you will continue to be a really high value asset for that company, and they will continue to pay you well in order to stay in that role. I listed like 60K as the average starting. To put that in perspective, that puts you like comfortably in the middle class and means that like if you were to get that kind of pay coming out of school, it's likely that you'll be able to pay off your student loans if you're able to like get and keep that job for like 5 to 10 years, right? That is, of course, I say that with a grain of salt. Everyone's situation is going to be different, and the amount of money that you need to like live or like to help support your family or what have you is different, but this is like relatively high in terms of careers coming out of school. And actually it's pretty high among engineers altogether. I think like, and honestly, I think this number might be going up still. This is a number for Wisconsin. In places like California, where the cost of living is much higher and where it's like the big tech excitement craze, they're paying engineers more like $120,000. But that in California is a lot closer to their poverty line, actually. So while that number sounds big and exciting, the cost of living out there is so high that that number is actually not all that big. But 60K in Wisconsin is actually like, that's huge. Like I recently bought a house because I like could afford to do that a couple of years out of school with like the salary that I'm making, which is not 60K for what it's worth. I don't want to like give you skewed information. Okay, further, the third point. This is kind of what I alluded to with being able to be a super high value. You can take this software knowledge and bring it into any industry. So if you start working in software in like manufacturing, which I personally think is super boring, I would be able to say, this is not for me. I'm going to move into the cannabis distribution industry, or like start building things for animals if I like animals. Like you can really take this anywhere you want. Next is that your ability to work remotely is basically just up to the company. I personally, like our company does not have an office. We all work remotely, and other companies in like Milwaukee in particular, like of all the software engineers that I know, maybe like 2 of them are required to go into the office out of like the 15 that are my like close acquaintances. And everyone pretty much just chooses to work from home because they can. The last point I made here is that like with everything changing very quickly, there are lots of opportunities to become a new expert. So if you do want to be the best of the best in a particular thing, there's lots of opportunities to do that, because I mean, people like me are saying, I don't really want to be the best of the best in any of these. I want to be able to be good enough at it to like make the things happen that I want, but I might need to lean on someone who's the best of the best at this particular technology so that I can use it to the best of my ability. And so if you become an expert in a particular technology, then you become very valuable, and that's exciting. Okay, last thing here. If you have listened to me ramble for this last hour and you're like, this is cool, I want to get into it and I want to start now, I've listed some resources here for you to start learning to code. The first one is Coding Bat, and then I'll show an example of what that looks like, actually. I mean, it's already been an hour, so like, why not make it an hour and a half? You know what I mean? So Coding Bat, it lets you practice Java and Python. Java and Python are both two different languages. And so let's do warm up 1. Okay. Has teen. Let's do this one. Okay. So basically what this will do is, let me make this bigger. It'll give you some kind of like problem to solve and says, okay, we'll say that a number is a teen if it's in the range 13 to 19. Given 3 integer values, that's what int is short for, return true if one or more of them are a teen. So if you can see it gives us an example. If it gives us these numbers, that's true, this is true, this is true. But if we were to pass in like 20, 10, 10, it would be false. So what this has you do is practice using the language Java. And so it's worth like doing some introductory courses on like what the syntax of Java looks like, because I'm about to start typing in it, and I only know that because I know what to type. But essentially what you're doing here is saying like, okay, if A is greater than or equal to 13, and A is less than or equal to 19, then we want to return true. And now we'll do that for the other letters, B and C. So we'll say additionally, like else if B is greater than or equal, and so on and so forth. And so this has you do a bunch of little exercises. And I wonder if even like what you can do to start learning this even too is it'll show you the solution if you want. And so you could read these solutions and then start to get an idea of what you might type for the other problems. So this is Coding Bat. I like this. I think this is fun. Like once you learn the syntax of writing like if and doing returns and doing true, which is a Boolean. A Boolean is either true or false. I think that's cool. Scratch is another one. This is the drag and drop that I explained earlier. And so a lot of people will use this to make games. So, I mean, we'll just click on a featured project. So this is a project that somebody else has made. And then I think, yeah, if you click see inside, it'll show you all of their code. So this is stuff that they've dragged and dropped. This, honestly, this is confusing. And so, like, maybe don't pick a featured project to explore first, because, like, it would take me a long, long time to look at this and know what it means. But you could start your own project here and say, like, so you go to Scratch and then you go to Create, and now, like, let's start with, like, when flag is clicked. So I'm going to give us a quick little crash course here, because the flag is, like, what you start in this top right corner, and you have this sprite, which is what they call it. So, like, it assumes that you have access to this, and then you click the green flag to start Scratch going. I'm assuming they have tutorials here, but let's, like, play sound meow. I don't know if you're able to hear that, but it just meowed. So, like, I just did a thing in Scratch. And so then it has different things for looks and sound and events. So, like, when the sprite, which is the cat here, when that's clicked, you can do stuff. And so then people use this to make games. And it's very cool. So Scratch is a fun resource. And then W3 Schools, I think this is where I would recommend actually starting if you have never, ever, ever coded in your entire life. So this is JavaScript, not Java. Java tutorial. So now if I did this Java tutorial, I start learning Java now. This will give me some background information. I'll say whatever, that's fine, I don't care. I think this gives you the setup to like start doing it on your machine. Oh, so this gives you like a fun little playground. So system.out.println. So this is what we use to like print to this little screen over here. So now I could say, I want this to do Sabrina. And it's taking several seconds, but it did Sabrina. So there are different resources like this to get started learning and practicing. And if none of these are your cup of tea, I mean, Google around, find another one. There's lots of free resources out here. And learning to code, like, and maybe you don't do any of this and you just start a degree program and expect them to teach you. And that's totally fine. People do that all the time. But know that you might hate it when you start. Maybe you won't, but it's nice to like get some practice and say like, do I hate this? Yes or no? And that's it. If you have any questions, like I said, I gave this presentation originally for high schoolers. And so if you have any questions, please drop them in the comments. This is a long presentation. So I like to think I've answered a lot of your questions, but because I've brought up so much, it's very likely that something is confusing and you have some kind of question. So please drop it in the comments. I'm sure you're not the only person who's wondering. And that's it. Thank you for watching at this point. I hope this was helpful in informing your decision of whether or not software engineering is for you. And yeah. Bye-bye.